The objective of our project is very simple, to measure the flow rate of falling water and then later passing the water through the turbine to creating a voltage. And then using the flow rate and voltage measurements, we can find the relationship between higher flow rate and higher voltage.
The idea of our project originated from the hydroelectric power plant dams, specifically the turbines. We as a group thought out real-life applications for our system. We wanted to make it more consumer-based, and we wanted to pitch it to building developers to incorporate it into their new buildings. This would make their buildings more environmentally friendly and self-sustainable. So our system would go underneath their green roofs and collect all the rainwater and convert that potential energy
to build upon what my colleague Saeed was saying. We have a schematic here so we can see how our system works. Now the reservoir at the top could represent a reservoir that's on a green rooftop that collects water from runoff from the plants that are there or collects rainwater. Now that reservoir is going to drain through this restricting valve so that we can control the flow rate. After the restricting valve, we have a flow meter so that we can measure that flow rate. Following the flow meter, there's a turbine so that the water passing down will turn the turbine and generate a voltage. After the turbine, the water will come down here and enter this reservoir at the bottom. So you might ask yourself, why do we need this little restricting valve here? Well, that's going to allow us to control different flow rates so that we can measure them and see how they're going to relate to our output voltage. The restricting valve is going to be controlled by a Quanser motor. The Quanser motor is going to be hooked up to a DAQ so that we can control its position with the laptop here. Now controlling the position of the Quanser motor is going to allow us to control this valve so that we can have different flow rates. So let me talk to you here about the flow meter. Why don't you follow me over to another picture. Hi there, welcome back. So now I'm going to talk to you about the flow meter. But this type of flow meter, this is a pulse output flow meter. The reason why it's a pulse output is because this pulse sensor here generates a pulse. And that pulse is based off of this. So here we have a fan blade. So as water is passing through it, the fan blades will turn. And this specific blade here is magnetically charged. So as it passes the Hall sensor can detect that magnetic field and generate that pulse. Now, we need to go back over to the other diagram because I have to explain something about how we're going to take this data and display it. So why don't you follow me back over there. Alright, so now that we know how this flow meter works, why don't we look at how the data is going to get processed. So from this flow meter, we're going to get that pulse. Now that pulse needs to pass through an amplifier so that the DAC here will be able to read that data. And then that data will then be passed here to our laptop so that we can display it on LabVIEW. And of course, we'll have to do some creative coding to turn that pulse into liters per second or liters per minute. So now we know how the valve here works, we know how the flow meter works. Now we need to figure out what we're going to do with this turbine here. So as the water is passing through it, it's going to rotate the blades that are inside. Rotating those blades is going to generate a voltage. Now if we come over here, we're going to be measuring that voltage using the multimeter because we want to know what kind of changes changing the flow has with our voltage. But since we're generating a voltage, what are we going to do with it? Well, why don't we do something like this? We can just simply power your household items like a light bulb here. There's endless possibilities that we could have with electrical power. That's just one of them.